To obtain a Part 107 FAA certification, also known as a remote pilot certificate, you must meet the following requirements. Be at least 16 years old. Be able to read, speak, write, and understand English. Be in physical and mental condition to safely operate a small unmanned aircraft system, SUAS. Pass an initial aeronautical knowledge test at an FAA-approved testing center. Obtain a FAA-recognized identification, such as a driver's license or passport. To prepare for the initial aeronautical knowledge test, you can study the FAA's Small Unmanned Aircraft Systems, SUAS, Airman Certification Standards, ACS, and the Remote Pilot, Small Unmanned Aircraft Systems, SUAS, Study Guide. You can also consider taking an FAA-approved training course or using online study materials to help you prepare. Once you have met these requirements and passed the initial aeronautical knowledge test, you can apply for a remote pilot certificate by completing the FAA's online application process and submitting the necessary documents and fees. It is important to note that the Part 107 certification is only valid for commercial drone operations. If you want to fly a drone for recreational purposes, you do not need a Part 107 certification. Instead, you must follow the FAA's guidelines for flying a drone recreationally, which include flying only for personal enjoyment, staying below 400 feet in altitude, staying at least 5 miles away from an airport, and not flying over people or moving vehicles. The Part 107 exam, also known as the Initial Aeronautical Knowledge Test, covers a wide range of topics related to operating small unmanned aircraft systems, SUAS, for commercial purposes. The exam consists of 60 multiple-choice questions, and you must correctly answer at least 70% of the questions to pass. Here are some examples of the types of questions you may encounter on the Part 107 exam. Regulations: questions about the rules and regulations that apply to SUAS operations, including Part 107 and other relevant FAA regulations. Airspace: questions about airspace classifications, altitude limits, and other factors that may affect SUAS operations. Weather: questions about how weather conditions can impact SUAS operations, including winds, visibility, and temperature. Performance and limitations: questions about the performance and limitations of SUAS, including how to calculate weight and balance, and how to determine whether a SUAS is capable of a particular task. Loading and maintenance: questions about how to properly load and maintain a SUAS, including inspections and pre-flight checks. Emergency procedures: questions about what to do in the event of an emergency or malfunction during SUAS operations. Radio communication: questions about how to use radio communication equipment and procedures when operating a SUAS. To prepare for the Part 107 exam, you can study the FAA's Small Unmanned Aircraft Systems, SUAS, Airman Certification Standards, ACS, and the Remote Pilot, Small Unmanned Aircraft Systems, SUAS, Study Guide, or consider taking an FAA-approved training course. These resources will provide you with the knowledge and skills you need to pass the exam and safely operate a SUAS for commercial purposes. In the United States, airspace is classified into different categories based on factors such as altitude, location, and the type of aircraft that are allowed to operate in each area. The main airspace classifications are: Class A, this is the highest level of airspace, extending from 18,000 feet mean sea level, MSL, up to and including 60,000 feet MSL. Only Instrument Flight Rules, IFR, aircraft are allowed to fly in Class A airspace, and a pilot must have an IFR clearance to enter this airspace. Class B, this airspace is typically located around major airports and extends from the surface to 10,000 feet MSL. Both IFR and Visual Flight Rules, VFR, aircraft are allowed to fly in Class B airspace, but a pilot must have an IFR or VFR clearance to enter this airspace. Class C, this airspace is typically located around smaller airports and extends from the surface to 4,000 feet MSL. Both IFR and VFR aircraft are allowed to fly in Class C airspace, but a pilot must have an IFR or VFR clearance to enter this airspace. Class D, This airspace is typically located around even smaller airports and extends from the surface to 2,500 feet MSL. Both IFR and VFR aircraft are allowed to fly in Class D airspace, but a pilot must have an IFR or VFR clearance to enter this airspace. Class E. This is the largest category of airspace and includes all airspace that is not classified as Class A, B, C, or D. Class E airspace extends from the surface to 18,000 feet MSL and can be found around both large and small airports. Both IFR and VFR aircraft are allowed to fly in Class E airspace, but a pilot must have an IFR or VFR clearance to enter this airspace in certain circumstances. Class G. This is the lowest level of airspace and includes all airspace below 1,200 feet AGL, above ground level, that is not within the boundaries of Class A, B, C, D, or E airspace. Both IFR and VFR aircraft are allowed to fly in Class G airspace, but there are some restrictions on the type of operations that are allowed. It is important for pilots to be familiar with the different airspace classifications and the rules that apply to each one, as this is a key factor in maintaining safe and efficient air traffic control. Weather conditions can have a significant impact on small unmanned aircraft system (SUAS) operations, and it is important for pilots to consider these factors before flying. Here are some ways in which weather conditions can impact SUAS operations. Winds. Strong winds can affect the stability and control of a SUAS, making it difficult to maintain a steady hover or fly in a specific direction. High winds can also increase the risk of collision with objects or other aircraft. Visibility. Poor visibility due to fog, rain, or snow can make it difficult to see and avoid obstacles, increasing the risk of collision. Temperature. Extreme temperatures can affect the performance of a SUAS's batteries, sensors, and other equipment. For example, low temperatures can reduce the battery life of a SUAS, while high temperatures can cause overheating and damage to the electronics. It is important for pilots to check the weather forecast and consider the potential impact on SUAS operations before flying. If the weather conditions are not suitable for safe flight, it is best to postpone the operation until conditions improve. In some cases, it may be necessary to obtain a waiver from the FAA to fly in certain weather conditions. I would like to express my appreciation to the listener for taking the time to listen to this information about obtaining a Part 107 FAA certification. There is links in the description to the best study guide available.